I want to say that if you have any questions or something, you can stop me. I've hidden the hard part of myself, so it will not bite tonight. Yeah, it's okay. So, Alexandra, I'm working in aerospace. I'm an aerospace engineer for about 7 years now. And 6 years I worked in composites. It's one of my passions. I like it a lot. I like those materials. Today I would like to give you a small introduction about composites. We will talk about some generalities, then the properties and the applications of composites. So, can anyone tell me what is a composite material? Any ideas? Except Xavier. No, I'm kidding. So, any ideas? I don't know.
A combination of two materials.
Yeah?
And it's most of the time it's I don't know how to say. Fabrics.
Indeed, yeah.
Fabrics,
Yeah. I should say except Theo as well, huh? Except a lot of people here. Yeah, so indeed you're right. It's actually a combination of materials that are mixed together, are put together in order to create another super material, to say so, another material that is better from properties point of view than the materials that were created from. So here we have two different composite materials. One is here, that it's called a sandwich material, and this one is a laminate material, but both are composite materials. I'll explain later what is the difference between them. So, I'm coming from Romania from the beginning, and in Romania there is no difference between sandwich and tartine. But since we are in Belgium, I think everybody can tell me what's the difference, or can think of the difference between a sandwich and a tartine. Huh? Can you think about it? So a sandwich? No. Yeah, probably, but I would like to think about the components. What's inside the sandwich and what's inside the tartine. Yeah, we're hungry, me too. So, well, sorry if I'm not correct, but one of them has the cheese, the spread cheese in it, and the other it doesn't. So if you want to see it like this, the difference between one and the other is the fact that one has glue inside and the other doesn't have the glue. So basically, that's what I would like to say in a sandwich. The fact that you have the sandwich inside, you have the compound inside, the material, but you also have to glue it somehow to the other materials. So that makes the difference in composites as well. For example, here you have the fiber, yeah, like Theo said before, and then you have the matrix. And after you will make the composite. So like we started from the beginning, you have one material, which is the fiber, which has high strength, high stiffness, low density, and so on and so on. And then you have the matrix that has good shear properties. Mix it together, you'll get the composite that will have both. And the high strength, high stiffness, and the good shear and properties. So, why choosing composites? Why cannot do it from metallics, for example? Like an aircraft, maybe it will be easier, no? Maybe it will be cheaper, I don't know. Why choosing? Because the properties, like I said, are superior from the properties of the materials that were constructed. On top of that, you cannot construct an aircraft or something only from fibers or only from the glue. Like you can't make a sandwich only with, I don't know, some mustard or something like this. That's not a sandwich, yeah? Also, you can see that from alternating different fibers in the matrix, you will get different strengths in different areas. So that will make also the material, the composite material, to be superior. But we have to keep in mind that the primary load carrying element is the fiber. So we have the fiber and the matrix, so the fiber will take the load. The matrix will just ensure the fact that the fiber stays in place and we'll keep it together. We can have different type of composites and hence different type of properties. Like for example, we can have unidirectional or bidirectional, so we can put fibers in one direction, in two directions, or many other directions. An important thing is to remember that we can put it only at 0, 45, 90, 0, 45, and so on and so on. It's important to respect this clock. The range of strength and thickness are determined by the orientation of the plies. So if the plies are like this, like I said, if the fiber is the primary carrying load, it will be like this, the load. If the fiber is like this, then the main load, it will be in that direction. It's relative, the weight also, it's relative to the stiffness and strength, but this composite mainly, basically, is less weight, is less massive than a metallic part. For example, carbon reinforced composites is 5 times stronger than the steel, but has 1/5 of its weight. So it's really, really light compared to metallics, for example. Yeah, and then the applicability. Where can we use composites? Can I make a shoe of composite? Do you think so?
Yes. If you want to, sure.
Yeah. Honestly, I think it's nowadays everybody talks composites, and everybody try to use it everywhere. I don't know. I don't even think of things that I've heard, but it didn't start it from there. Or let's say that the applicability is not that large that we would like to, because we have to test, we have to see if it's working, if it's not working, and so on. So basically, it's used in aerospace. That we all know. We have here an image that I've taken it from Google, from the internet. You can find it everywhere. So nowadays aircraft, that it's almost full composites. Is it good, bad? It depends. Yeah, I'm not God or nobody to say if it's good or bad, but the idea is that if someone uses it, it means that it uses it for a reason. That's for sure. It saves some money because it's lighter. On the other hand, the strength, it could be better, but it could be worse in some points as well. So it has to be seen. NASA, as usual, is continuously looking to improve the composites and to use it more and more and more. Afterwards, in the architecture, it sounds strange, I know, for me as well, but I've seen houses made from composites, because the panels, actually, they are, you can put it, and the sandwich structure that I showed you in the previous slides, you can use it as a wall, for example. And I've seen also in the design of the houses, like chairs or tables and stuff like this made from composites. So they are very manageable. In automotive, and maybe Yassine knows. Yes, please.
Slide before.
Yes.
Would you consider concrete, armed concrete, as a composite?
Yes, you can. I will not, personally, me, but but you can.
Okay.
Yeah.
So it's not
Depending, you're making concrete from two parts, and separately they don't have the properties that are together. So personally, I will not.
Why not?
Well, for me, composite, it should have carbon, glass, and resin. So that's maybe it's just a personal thing. So for me, concrete, it's not composites, but
Be careful. We are using fibers on concrete also to replace the metallic wire.
Yeah, but you don't have resin in there.
No.
Yeah, see?
On the top, yes, but not.
Yeah, but not as a matrix.
And you don't need carbon fiber for composite material.
Sorry, maybe I didn't
You
get
said
it.
carbon?
Yes,
Fiber?
carbon or glass fiber.
But you also have different types of fiber, like floss. I don't know if you know that.
Kevlar? Yes, but that's also, that's also. Yeah, So basically, this is what I fiber and the resin. This is what I consider. Concrete for me, it's much more heavy. I see composite like something very light, you know. This is how I see it, something very playable. Concrete, you put it and you have the building. That's it. Okay. Any other questions? No? Then the automotive, and like I said, maybe Yasin knows, and I also saw something interesting in your bag. I think it was the one with, I have laser view, I forgot to tell you. And yeah, it was the thing, the white thing with, exactly. So that's also like a composite, you know, so you can use it. And I know it's used indoors, in skins, in even in the, how do you call it? So because they are lighter, because their aerodynamics is better, and because of other reasons, of course. In energy, the pairs that you can see, if you are traveling, for example, to Netherlands, you will see also in the sea a lot of stuff like this. Also in Belgium there are a lot, so basically all the pairs there are made from, the propellers are made from composites. The concrete, in the like you see, it's a bridge, it's a highway here. So in this case, this is also a composite, so it's interpreted and used in that sense, of course. But infrastructure, all kind of infrastructures, you can use composites. In the marine industry, and if I'm not making a mistake, I think it started from there. So in the marine industry, you also use composites everywhere. Yeah, because the fluids, the fluid is the water, then the fluid, the air, and so on. So it's going hand in hand, the marine and the aerospace. So in that case, it's used also for a lot of boats, and for high power boats, it's quite intensive used. For pipes and tanks, and that was surprising for me as well, but apparently it's used also for this one, because you can arrive to have, the composite itself, they have high strength in heat and so on, so it's okay to use it also in pipes and tanks. And for pleasure, for bikes, and I really know some persons that they are trying to build a bike here in Belgium entirely from composite. So it's quite amazing, Okay, so that was it. Maybe too short, maybe not too short, I don't know. Thank you.
Okay.